In a small town of colonial India, far removed from the great universities of Europe, a mind was unfolding that would challenge the very foundations of mathematics. Srinivasa Ramanujan was not shaped by elite classrooms or formal training. He was shaped by obsession, intuition, and an almost mystical connection with numbers. Born on December 22, 1887 in Erode, Tamil Nadu, Ramanujan grew up in modest circumstances. From an early age, numbers spoke to him in a language only he seemed to understand. While other children learned arithmetic, Ramanujan felt mathematics at the town higher secondary school in Kumbakonam. His brilliance in mathematics was undeniable, but so was his indifference to everything else. Subjects outside mathematics faded into irrelevance. For him, numbers were not tools, they were truths waiting to be revealed. At the age of 15, a single book changed his destiny. George Shoebridge Carr's Synopsis of Elementary Results in Pure and Applied Mathematics. It was not a textbook, but a bare list of thousands of theorems with almost no proofs. For most, it would be incomprehensible. For Ramanujan, it was fuel. He did not just learn the results. He re-derived them, expanded them, and went far beyond them. Alone, without guidance, he began creating original mathematics that the world had never seen. In 1903, his talent earned him a scholarship to the University of Madras. Yet, irony followed genius. His singular devotion to mathematics cost him the scholarship within a year, as he failed all other subjects. Poverty tightened its grip. Ramanujan lived on the edge, hungry, uncertain, but never detached from his numbers. In 1909, he married Janki Ammal in an arranged marriage, carrying family responsibilities alongside intellectual ambition. Salvation came briefly in the form of Ram Chandra Rao, a government official who recognized Ramanujan's extraordinary abilities and supported him. But Ramanujan refused to live on charity. Determined to stand on his own, he accepted a clerical job at the Madras Port Trust. By day, he worked with files and registers. By night, he wrestled with infinity. In 1911, the world finally began to notice. His papers appeared in the Journal of the Indian Mathematical Society. 2 years later, Ramanujan took a bold step. He wrote to G.H. Hardy, one of the most respected mathematicians at Cambridge. The letter contained pages of unexplained formulas, strange, beautiful, and terrifyingly original. Hardy knew instantly this was not imitation. This was genius. Despite religious and cultural barriers, Ramanujan traveled to England in 1914. At Trinity College, Cambridge, two opposites met. Hardy, the rigorous mathematician of proofs, and Ramanujan, the intuitive creator of results. Together, they produced groundbreaking work. Ramanujan reshaped number theory, infinite series, continued fractions, elliptic integrals, hypergeometric series, and introduced ideas like Ramanujan summation, concepts that still echo through modern mathematics. One of his greatest contributions lay in the theory of partitions, understanding how numbers break apart into sums. His work was so profound that even without familiarity with modern mathematical tools, he surpassed many who had them. In 1918, recognition followed at last. Srinivasa Ramanujan was elected a Fellow of the Royal Society of London, one of the highest honours in science. But brilliance came at a cost. England's climate and years of hardship weakened him. In 1917, tuberculosis struck. By 1919, he returned to India, fragile but unbroken. Even as his body failed, his mind refused to rest. Until his final days, he filled notebooks with discoveries, 3 notebooks and 1 mysterious lost notebook, rediscovered decades later, still challenging mathematicians today. On April 26, 1920, Srinivasa Ramanujan died at just 32. Yet, in that short life, he altered the course of mathematics forever. From a self-taught prodigy in India to a legend of global science, Ramanujan's story is not just about numbers. It is about faith in intuition, resilience against odds, and the belief that truth can emerge from anywhere, even from a mind that saw equations as thoughts of God.